In this video, we're going to take a look at variance and change of scale for continuous random variables. First one we're starting off with, we're asked to find the mean. We've got 2 and 5/9. Again, not quite sure why they're giving us a mixed number here, but that would be 18/9 plus 5/9. I'm going to write that as 23/9. And we're aiming to also find the expected value of 18x plus 5. So if you think about it, we've seen this already with discrete random variables. Like if we times all the numbers by 18 and we add 5 onto all the numbers, adding 5 onto all the numbers, if the average was, if the distribution was over here, if we add 5 to the distribution, it's going to change the mean, isn't it? And if we multiply all the numbers by 18 as well, it's going to spread them all out. It's also going to change the mean. So both of these things are going to affect the average. When we do variance for the next example, if you add stuff on, it doesn't affect the spread, does it? But the multiple does affect the spread. All right. So the expected value of x for this one, we'd integrate between 1 and 3, 1/6, multiply by x, so that would be 4x minus x squared, plus this one will integrate between 3 and 5, multiply by x before we integrate, so that would give us 1/6. Add 1 to the power, so 4x squared divided by 2, so 2x squared. Add 1 to the power, divided by the new power. X becomes x squared over 2. And the limits, let's be careful, the limits for this one are 3 and 1. And the limits for this one are 5 and 3. So subtract, don't forget the bracket, so that'll be 2 minus 1/3. And we've got plus 1/6. 5 squared over 2 minus 3 squared over 2. I'm going to just, I mean, I could obviously do this on the calculator, but the answer's given. I'm just going to write 23/9. Okay. It's up to you guys. You got to think about, like, if you're in the exam, like, how much time have you got? Like, if you've done enough, if the answer's given and you're confident in your working out, if you have got enough time, obviously do the calculation, because it'll tell you if you've made any errors in your integration. I probably will do that actually, but give me one sec. Yeah, I'm good. I've just checked. So we get 23/9. Obviously, use common sense. How much time have you got in the exam? You've got to do stats and you've got to do mechanics as well. If the answer's given, you've shown your method, feel free to just move on, as long as you have got enough, if you haven't got enough time, do the calculation as well. Part B, we wanted to get the expected value of 18x plus 5. So all we need to realise here is the change of scale tells us this is just 18 lots of expected value of x plus 5. If you wanted to, if you wanted to check, we do know as well, if you want the expected value of x, you multiply by x, don't you, before you integrate? Like, you can, it'll take you ages, but if you wanted to, because we're finding the expected value of 18x plus 5, the pen just doesn't work anymore. If you wanted to find the expected value of 18x plus 5, we could times by 18x plus 5. In both of the integrals, so times that one by 18x plus 5, times that one by 18x plus 5. But like, that'd take you so much longer. Like, look how long that one took us. We definitely don't want to do that. Like, you could do it that way, but it's much better if we realise that add 5 on, multiply by 18, and then we can just do. Okay, 18 divided by 9 is 2. So that gives 46 plus 5, 51. Okay. Second example, we've got a function which is 5x to the power 4 between 0 and 1. If you did want to sketch this one, x to the 4 looks like x squared. It's just, it gets steeper and it's a bit shallower down here. So we're thinking about this graph between 0 and 1. So the expected value or the average is going to be somewhere between 0 and 1, but obviously a bit closer to 1 because there's a higher probability of these outcomes up here. If you wanted the expected value of x plus 1, you could, if you want, you could multiply by x plus 1 and then integrate. But the way I'm going to do this is, first of all, I'm going to figure out the expected value of x. So let's multiply by x between 0 and 1. And you can take the 5 out if you want. So don't forget, be careful here. Sometimes people think they've integrated. You know, when you multiply by the x, you've added 1 to your power. We haven't integrated yet. Okay, we have to remember expected value of x times by x, and then integrate. So that would give me 5 x to the 6 divided by 6. 1 and 0. So if we sub 1 in, we get 5 over 6 minus sub 0 in. So the expected value is 5 over 6. Alright, so if this whole distribution, if we add 1 to everything, think about what would happen. Like the expected value, if that's what x looks like, the expected value of x plus 1, well, x plus 1 would be over there. So the average would also increase, wouldn't it? Like we could just say, therefore, the expected value of x plus 1 is equal to the expected value of x plus 1, which is 5 over 6 plus 1, which is 11 over 6. And it makes the integration a bit easier as well. You don't need to multiply by x plus 1. So the second part says the variance of 3x plus 1. But let's start by finding the variance of x. So that's the expected value of x squared minus the expected value of x squared. Same formula as for discrete, but obviously we've got a different way of finding these. If I want the expected value of x squared, then I'm going to have to multiply by x squared before I integrate. Right, don't forget that, guys. Expected value of x squared, just multiply by x squared. That would work for any function. The expected value of anything, just times by that before you integrate. Expected value of x times by x, expected value of x squared times by x squared, expected value of 1 over x times by 1 over x. Okay, we integrate over the whole function, which is between 0 and 1. So we can take the 5 out if you want, but we've got 5x to the 6. Add 1 to the power, divide by the new power. Limits at 1 and 0. So if we sub 1 in, we're going to get 5/7 minus sub 0 in. So the answer is just 5/7. So the variance of x, highlight this in your notes. You don't get it in the formula booklet, you do need to remember it. It's the expected value of x squared minus the expected value of x all squared. So the expected value of x is 5 over 6. So if we do 5 over 7 minus 5 over 6 squared, that gives me 5 over 252. Okay. So the last thing we then do is we think about how to change the scale effects. So obviously if we add 1 onto all the numbers, it doesn't affect the variance. The variance is a measure of spread, don't forget. if I wanted the variance of 3x plus 1, that's just 3 squared times the variance of x. So if I times my answer by 9, which is 3 squared, I'm getting 5 over 28. And obviously, if we ask for the standard deviation, all we have to do is just square root, because we know the variance is the standard deviation squared. Okay. Thanks, guys.